Hello everyone, finally we are in level 5 robotics, which is autonomous robots. And autonomous robots which are more capable of performing autonomy, which is nothing but to find out its own path. That is one good example of autonomous robots. And as you can see here, there are two different type of robots that is mentioned. The first one is a turtlebot. Turtlebot is a very big company which is currently active in educational robotics side, and it has currently three different versions, which is burger, waffle, and waffle pie. So each robot, which is based on same circuitry, same hardware, but it has different sensors. And most of the turtlebot is only made for like lab use. It cannot use outside of environment. Whereas there is another robot which is called Husky robot. It can work in outdoor environment, and it is more robust than these turtlebots. It has different sensors. You can add multiple sensors on this on the top of this chassis. You can see here camera, you can see lidar, obstacle sensors. There are n number of sensors that you can add into this robotic platform, and you can use it for your robotics application. So these are the two different options that you can use, or else you can make your own robot. But let's understand exactly what is autonomous robots. What is autonomy? So as you can see, these building blocks you can see before, but now I will explain one by one each exactly what are the different functionalities of these specific levels. So I will start with the switches. Switches is very basic thing which you are seeing from like your first from level 1 robots, and it has like 2 stages or 3 stages, or else multiple stages. You can use any type of switch which can act as a different input for the robotic systems. So let's say you build a robot, and that robot has two different levels, two different stages. So in one stage your robot can act as a manual control with your laptop or with your computer, and second one it act as a autonomous robots. So in this case you can use the switches, different or multiple switches which can perform this different switching between a different states, manual switching. So for these specific reasons you can use the switches in your robots. Second is the proximity sensor. Proximity sensor is nothing but ultrasonic or infrared sensor which you can use to detect an obstacle or a long range obstacle, which is which you can detect by this sensor. Third one is GPS and IMU. GPS is nothing but you can get lat and longitudinal coordinates of your robot with respect to the earth frame, and that earth frame will provide you some raw data which you have to further process, and you can run your robot autonomously. And if you integrate the IMU with the GPS, then it will be more uh, more convenient to provide some like planning approach by IMU. And IMU is nothing but inertia measurement unit. By using that you can get exactly rotation and orientation of your robot, and by using these two you can do a very better task, which I'll tell you in some time. Fourth one is a RGBD camera. In market there are a lot of RGBD cameras are available. The Intel RealSense, then Asus, then Microsoft Kinet. So these are the cameras that you can use for depth calculation, and there are a lot of different applications. Like I'll tell you a single application, that is a point cloud. So by using that you can make a different map, 3D map of your environment, which is you can further process and you can use for like autonomous navigation. So these are the all terminology I will explain in the next slide, but these are the different applications of this specific sensor. The the fifth the four the next one is the lidar. Lidar is nothing but excuse me lidar is nothing but a 360-degree scan of your robot. It's nothing but a single slice plane of your across your robot, so you can get a clear view of application, and which is very used to build a map surrounded by your surrounding by a robot. So these are, and the last one is encoder. So how much your distance you traveled by your robot, that you can keep track and you can predict that exactly what is the position of your robot. So that is mostly useful when you're using encoders into your systems. So these are the all high level sensors that you have to use in your robot if you want to enter into the level 5 stage. And there are power supplies, nothing but like 5 volt or 12 volt or 18 volt power supply, which you can use to drive these sensors, your processor and motors. The processor is a big stage. Processor can be a single processor or it can be a multiple processors. So there are sensors which are like which uses a advanced processor like RGBD camera, lidar, and yeah, these two sensors require a higher power of computation. So that Raspberry Pi or Nvidia Jetson are the good example for like processor. But if you can use your laptop for as a processor, so you can process your real-time data with your laptop. And there are multiple small processors or microcontrollers, you can say like Arduino board or any AVR microcontroller or any 8-bit microcontroller, which is used for like proximity sensors, switches, GPS and encoders. So you can distribute your entire system into the not only a single processor, but you can distribute amongst all the different small processors, and you can integrate into the single system. So at this way, all the hardware side of your autonomous robots that is divided, and all the different nodes or all the different controllers, they communicate with each other. Each node handle their own specific task. A node can handle motor actuators, or else few nodes can handle your low level sensing. There are different nodes which handle like RGBD or lidar camera. So in this way you can divide your entire system into the multiple distributive units. And there are two approaches that I would like to mention. That is, first one is a global approach and first one is a local approach. That is global planning and local planning. Global planning is nothing but like, let's consider if you want to travel your robot from like point A to point B, and you have lat and lon coordinates excuse me, lat and lon coordinates of your source and your destination. So in this case, this is nothing but a global planning approach, so that you have to globally, you know that yeah, your robot has to travel from this to that. But while traveling in this specific path, you must know that yeah, these are the small obstacles that you have to avoid. So for that reason, you can use all these small level sensors like proximity sensor, then RGBD camera, then encoder. So these are the small things that you have to take care of if you're planning to build your autonomous robots. And there has to be some indicators which always display your robots exactly what is the state of your robot, what your robot is doing. It can be a remote or it can be a on board of your robot. You can add basic small LCD which will show the you, yeah, this is the robot currently working on, these are the errors, these are the problems that robot is currently facing. So in this way you have to divide entire system into your entire robotic thing. So motor controller is nothing but same edge bridge, or you can use any ready-made controller. And motors are nothing but very special one which has capability of encoder feedback, and that encoder feedback you can pass on with this like encoder block through the processor. So at this way you have to build your robot. So once you've done that, you have to perform like basic experimentation. So there are multiple experiments. I'll tell you. First one is a navigation. I'll tell you navigation and sensor fusion. Navigation later on. I'll tell you sensor fusion. Sensor fusion is nothing but integration of all these different sensors, proximity, GPS, RGBD, lidar, and encoder into the single output, and that single output will give you a motion to your robot, exactly where it has to travel and when it has to stop. So that is nothing but a sensor fusion thing. Next one is a SLAM. SLAM is a very core problem of robotics, that is simultaneously localization and mapping. So with this approach, what you have to do is that using your sensors, you have to take a reading, take a observation of your environment. So as you can see, this robot is observing exactly where he is traveling. So the everything is exploring once it travel through the path. So initially you have to take an observation surrounding by your robot, and your robot has to know that exactly where it has to travel. So that is simultaneously robot has to localize and also make a map of the environment. So these are the two things that robot has to follow in this SLAM problem. If you perform this SLAM, it is more like more advanced thing, which is more advanced thing in the robotics. And by doing that, you have to learn like small concepts like filtering, Kalman filtering, or else particle swarm filtering. And there is, you have to understand like higher end applicative ends, such as you should know exactly what is ROS or any kind of socket based protocol, so that your multiple nodes can communicate and it can process simultaneously, and it will create map like this. Or you can see here, this small robot is creating map, 2D map. This 2D map can be generated using lidar sensor. So these are the different application of like SLAM. So if you add SLAM, and there is one more thing, is that is planning. So that is a fourth approach. Planning is nothing but traveling your robot from like point A to the point B with some specific algorithm. So there are different like algorithms available, like die star or A star, or different type of algorithms available. That algorithms you can implement into your robot, and that robot will travel accordingly. So even self-driving vehicles are using different algorithms like anti-star algorithms in order to travel from like point A to point B. So these are the different things that you can follow in order to solve your local planning and global planning problem. So your robot will travel accordingly. And once you add your SLAM plus path planning, that thing is nothing but your navigation. So navigation consists of SLAM in addition with a planning. So navigation is very bigger field. Navigation consists of three major sensors. One is GPS IMU, lidar, RGBD camera, and encoders. So once you fuse all these four sensors into the single one, then you will get exact abstraction, exactly where you have to travel, where your robot is moving, traveling, and where it has to go. So these are the small applications that you can use. And there are multiple things, like you can use multiple robots use a different SLAM technique. So at the end of the day, you can combine both the map of these two different robots with each other, and you can make a bigger map. Or else you can use a one ground vehicle, one your flying robot, so that you can make a flying robots map with your ground robot map. There are n number of application, and application is varies with like your different problem statement. So if you want to make map for like indoor environment like this, so excuse me, so your output will be different. But if you want to go in the outdoor environment, then your output will be different. So it varies with your ambience, your different situation. There is not a novel approaches present for this specific kind of robotics level. So this is more interesting field. You can enter and you can start exploring by yourself. You can make your simple robotic systems, and you can build by yourself. There are a lot of tutorials available. You have to understand ROS, you have to understand basic how it works, how the socket based protocol work, and how you can make your robot on the top of that. So this is all about level 5 robots. And I would like to tell one more thing, which is the most important thing of this video series, that is pyramid. So at this point of time, you understand everything about levels, like level 1, level 2, level 3, level 4, level 5. So my suggestion, or what is our suggestion, GreyRobotics suggestion, it would be, so if you don't know anything about robotics, then start building by level 1. And once you understand exactly how level 1 works, and you can add that level 2 on the top of level 1. So that at this way, you have to just build a pyramid with the different levels and different level of abstraction, so that you will understand, yeah, these are the levels that you cleared, these are the levels that you understand by yourself. And this is how you have to follow. You cannot start with a direct file level 5 or level 3. You must know the basic background of exactly where were you and what you want to do and which thing you understand. Because nowadays a lot of students directly start with the ROS and all that kind of thing, but they don't know how motor works, how differential drive works, what is linear velocity, angular velocity. So first you have to clear all these basics, and once you done that, then you have to enter into the higher level of autonomy. So once you enter into the level 5 is more better for like you can say that you are the actual robotics engineer. if you reach level 1 by yourself. And if you perform any basic application like in level 5, then you can consider, yeah, you understand robotics very well. Rest of the things are just like basic building blocks that you have to understand by yourself. So you can follow this tutorial. And really, thanks for the watching. This is a very big series. Let us know if you really like this series, and we are planning to make more series after that. All the best for your robotics journey. I hope this tutorial will help you for your journey. Comment below if you have any query, or if you want to communicate with us. You can email us, you can comment below. And if you like GreyRobotics products, and you can purchase from Amazon, you can visit www.greyrobotics.in. If you have any inquiry, if you want any consultancy, if you want anything, you can just email us anything, your problem statement. Yeah, thanks for the watching, guys. Bye, have a good day.